Welcome to Hired in IT. Our mission is simple: help you build the skills that employers actually want. Whether you're trying to land your first IT job, switch careers, earn a promotion, or increase your salary, we're here to help. Every video is thoroughly researched and designed to make complex IT topics easy to understand. If there's an IT topic you'd like us to cover, leave a comment below. We may turn your suggestion into our next video. Turning IT knowledge into career opportunities. Consider this: a developer integrates Azure AI search into a customer portal and accidentally leaves the admin API key inside the front-end JavaScript. Anyone who inspects the network traffic or source code can grab that key. With it, they can query the entire search index, extract sensitive data, and potentially modify or delete content, all without breaking in. This hypothetical scenario shows why securing keys is the first line of defense in knowledge mining. In this video, we'll build a pipeline that eliminates these risks. By the end of this video, you'll own all three skills outright. You'll deploy a zero-key knowledge mining pipeline that extracts patient names, dates of birth, insurance IDs, and even line items from invoices, without a single static secret anywhere. You'll train a custom document intelligence model on your own forms so you're not stuck with generic pre-built outputs. And you'll lock down query access with Entra ID, Microsoft's identity platform, the modern name for Azure AD, and role-based access control, or RBAC, eliminating the exact mistake that caused our hypothetical leak. Let's turn that catastrophe into your ultimate security blueprint. Manual data entry requires a person to read each document, type fields, and verify for errors. It just doesn't scale. Azure Document Intelligence automatically extracts text, key value pairs, and tables from invoices, receipts, and forms using pre-built deep learning models. It processes documents in batches, slashing turnaround from hours to seconds, while raising accuracy and freeing your team for higher value work. Pair it with Azure AI Search, and you get a fully searchable knowledge base without a single line of copy-paste. Knowledge mining is the process of extracting usable information from large volumes of unstructured data, PDFs, images, scanned forms, and turning it into a searchable knowledge base. Azure AI Search provides a pipeline that ingests your documents, enriches them with AI capabilities like optical character recognition, and then feeds the structured output into a search index. You can optionally integrate Azure Document Intelligence to extract detailed form fields and tables so your application can query deeper than keyword matching. Before we move on, let's do a quick recall. What built-in Azure AI search skills can automatically enrich documents without custom code? An AI pipeline with Azure AI Search and Document Intelligence eliminates the grind of manual data entry. Upload your documents, and automatic OCR combined with deep learning models extract structured fields, tables, and key value pairs. Within minutes, enriched data flows into a fully searchable index, ready for your application. No overtime, no typos, just consistent, repeatable results. Let's pause for a quick recall. What two Azure services are combined to extract and search structured data from documents? Here's the core flow. Unstructured documents like scanned forms go through AI enrichment, which uses optical character recognition and other skills to extract text and structure. The result is a searchable index your applications can query instantly, turning a messy folder of PDFs into structured, actionable data. If you embed an admin key in client-side code, Anyone who inspects the network requests or source files can retrieve it. That key can grant broad access to your search service, potentially allowing queries, index modifications, or data deletion. Even if you think your endpoint is obscured, modern browser tools expose every string. In a production system, you should never expose secrets in the front end. Instead, use managed identities, an automatically managed service principal that lets a resource authenticate without passwords or keys, and token-based authentication to keep keys off the wire entirely. Checkpoint. Why should you never embed the Azure AI Search Admin API key directly in client-side code? Pause and think. The answer: admin keys grant full read-write access to all indexes. If included in front-end code, anyone can extract it and compromise your entire search service. Checkpoint. What is a common way a hard-coded API key can be discovered in a web app? Pause. The answer: anyone can open the browser developer tools to inspect source code or network requests, revealing the key if it's embedded in client-side JavaScript. Almost every breached pipeline follows the same four-step recipe. First, the storage account uses an account key that ends up in a config file. Second, there are no private endpoints, meaning no way to keep traffic inside your Azure virtual network instead of the public internet. Third, the team relies entirely on built-in text extraction, producing a flat content field instead of structured attributes like date of birth or claim amount. And fourth, the admin API key lives in the front-end application. Each of these alone is a serious risk. Together, they guarantee exposure. Checkpoint. How can a search service securely access data in Azure Blob Storage without using account keys? Think about identities and roles. The answer: enable a managed identity for the search service and assign it a role that grants read access to the blob container. For example, storage blob data reader. After disabling public network access and creating a private endpoint, the search service is completely cut off from the public internet. Only traffic from your virtual network through the private endpoint can reach it. So even if an attacker had a valid admin key, they'd get a connection refused. The endpoint doesn't exist publicly. Storage is the next domino. We create the account with public access disabled, default action deny, and a system-assigned identity. Then we disable shared key access, meaning no account key will ever work, even if it's sitting in a forgotten config file. Finally, we assign the storage blob data reader role to the search service's managed identity. The indexer will use its own identity to read blobs. The connection string becomes a harmless pointer, not a secret. You can lock down your blob storage by creating a private endpoint inside your virtual network, combined with a firewall rule that denies public access. This reduces exposure even if someone obtains a blob URL. The network will refuse unauthenticated calls from the internet. Document Intelligence Studio is where we teach the model to read your forms. Create a project linked to your AI services resource. Then upload a sufficient number of sample forms of the same document type. Consistency matters more than variety here. Label each field carefully: patient name, DOB, insurance ID, diagnosis code, claim amount. Use the same canonical name like DOB across all documents to avoid confusing the model. After labeling, train the model and note the model ID. It's just a reference the indexer will call later, with managed identity handling authentication. Checkpoint: identity-based access. To enable secure calls, we gave the search service a specific identity. Pause and answer. What Azure feature did we use to avoid storing API keys? We'll reveal after. The answer: a managed identity, which provides a token-based authentication flow. Assigning the Cognitive Services user role to the Search Services managed identity on the Document Intelligence instance can enable keyless access for enrichment skills. Instead of storing an API key, the indexer presents its own identity token, and Azure handles authentication. No secrets to leak. Recall check. You've just built a custom document intelligence model. Before you can use it in a skill set, what two things do you need? Pause and think. The answer: the model ID and the endpoint URI. For management operations like creating an index, you may be able to use Azure AD-based authentication instead of static keys. The specific method, bearer tokens, or managed identity depends on your exact scenario and service support. Always check the current Azure AI Search documentation for the supported authentication patterns. Checkpoint. What is a more secure alternative to hard-coding an admin key when managing Azure AI Search? Pause and answer. The answer: using Azure AD-based authentication, like managed identity or short-lived bearer tokens, can eliminate the need to store shared keys. But not all operations may support it yet, so check the documentation. A skill set is the enrichment brain of Azure AI Search. It chains AI skills that process documents step by step. First, the built-in OCR skill extracts printed text. Next, key phrase extraction pulls out salient terms. We can also use a custom Web API skill to call a trained document intelligence model's endpoint. Verify that the endpoint accepts the expected request format and returns the expected schema. The indexer can then pass a managed identity token so no API key is stored. Here's the full enrichment pipeline visualized. Raw documents in blob storage flow through OCR to extract printed text, then key phrase extraction surfaces the most relevant terms. Next, the custom Web API skill calls your trained document intelligence model to pull out structured fields like patient name and claim amount. Finally, the indexed data lands in your search index, filterable and searchable. Here's a sample indexer definition. Key settings like image action can enable OCR on images, and field mappings map blob metadata to the index. The exact configuration options depend on your data source and index design. Refer to the current Azure AI Search documentation for the complete reference. Open the Indexers tab in the Azure portal, find your indexer, and click Run. Then switch to Execution History to watch the enrichment pipeline process each document. You'll see successes, failures, and any warnings. Recall check. Earlier, we assigned a role to the Search Services managed identity to let it read blobs. Which role was that? Pause and answer. The answer: Storage Blob Data Reader. After you've moved your applications to token-based authentication, that old query key can still be used if it's out there. The fix is simple. Go to the Keys blade, find the query key, and regenerate it. That turns any leaked key into a useless string and closes the loophole. We assigned the Cognitive Services user role to the Search Services managed identity earlier. If the skill set hits a 403, one of the first things to check is whether that role assignment exists. Pause and think. What authorization step must be in place? We'll reveal it in a moment. So far, we've extracted single fields from forms. Invoices are messier: line items, quantities, totals. The pre-built invoice model returns an array of line items, and the enrichment pipeline can map those into a complex collection type in the search index. Each row's description, quantity, unit price, and amount become nested fields. The result is no longer a flat text dump. It's a structured ledger you can filter and sort. To store line items properly, the index needs a line items field of type collection of item complex type. That gives you a nested structure that can hold every line item on an invoice. The subfields, description, quantity, unit price, and amount can all be made filterable. This unlocks queries like, show me every invoice containing a line item over $500 using an OData filter expression. OData is the Open Data Protocol, a standard for querying RESTful APIs used in Azure AI Search. The skill set connects the pre-built invoice model to your enrichment pipeline. The URI points to your document intelligence resource endpoint using the pre-built invoice model. In the outputs block, you provide a source context that targets the items array so the indexer can iterate through each line item. Without this, the array stays opaque. Now the indexer's output field mappings bridge the enrichment tree to the index. For nested collections, one common pattern is to use paths that reference array elements. Here, we map description and amount from each line item into the collection field. Without these mappings, the extracted line items stay in the enrichment tree and never appear in your index. With them, you get a searchable, structured collection. Let's lock in the power of complex types. Pause the video and think, what's required to ask for all invoices where any line item exceeds $500? We'll show the answer right after. When pipelines break, error messages can be vague. Here's a handful of things you can check first. Forbidden often points to missing permissions. Timeout suggests the skill deadline may be too short. Bad request could be a wrong API version or malformed payload. An index out of range error might stem from a corrupted document and contains no keys. Typically means the index schema forgot a unique document ID mapping. Keep this list handy for your first response. Here's the gotcha that stumps almost everyone. You've assigned the correct RBAC roles, yet the indexer still returns a 403 when accessing blob storage. The real root cause is often DNS. The search service can't resolve the private endpoint FQDN. Spin up a test VM inside the same subnet and run inslookup conto sodoxprod.blobcore.windows net. If it doesn't resolve, make sure the private DNS zone privatelink.blobcore.windows.net is linked to the VNet and contains an A record pointing to the storage private IP. That one check can save you hours of chasing permission ghosts. Debugging a failed enrichment doesn't mean staring at logs blindly. Open your search service, go to Indexers, and look at the execution history. Click the failed run, switch to the Failed Documents tab, and expand the error details. You'll see the exact HTTP status code and message. Built-in skills often surface in the portal's debug view, but custom skills may require additional steps. Running the skill directly through the REST API or Postman can reveal the raw request and response, helping you spot wrong URIs, mismatched API versions, or missing roles that cause a 403. This tight loop saves hours of guesswork. Custom model training can fail in subtle ways. First, inconsistent field naming, like using DOB in one document and date of birth in another, can degrade accuracy, so unify names in Studio. Second, ensure your SAS token includes read and list rights so the training service can find your files. Third, split extremely large files before uploading. And as a bonus habit for teams, store canonical field names in a shared YAML file so everyone labels consistently. After fixing labeling inconsistencies, you hit a training error. No documents found. The culprit is often an expired or insufficient SAS token. SAS tokens are like milk. They go bad, and if you forget to renew, your training goes sour. Generate a new one with the Azure CLI, giving it read and list permissions and an expiry a month out. Missing the list permission is a common reason the service can't enumerate your blobs. If your compliance policy forbids public SAS entirely, the enterprise workaround is to train using the Document Intelligence REST API with a managed identity. No token needed. That path lets you build the model directly from your locked-down storage account through RBAC, like you already did with the indexer. A low confidence score means the extraction could be wrong. You don't want that junk automatically becoming a searchable fact. Bad data can mislead users. One approach is to inspect the confidence score on each field. If it's below your threshold, flag that record for human review. That way, your index stays trustworthy. Time for a quick recall. After locking down and enriching your search index, you hit a skill failure. What portal feature lets you inspect the per-document pipeline steps to identify where it broke? You never want to manually click Run Indexer every time a new intake form lands. With a schedule, the pipeline becomes invisible infrastructure. Set an interval, here, every hour, and Azure AI Search can automatically wake up and pick up new or changed blobs. For more immediate processing, you might explore event-driven patterns that trigger indexing when new data arrives. Also consider setting max failed items to a threshold, like 10, to prevent a few corrupt blobs from halting the entire run. Now your knowledge mining pipeline hums in the background, processing millions of documents without anyone babysitting. Contoso Healthcare Services. 5 hospitals, and the moment you mix patients from Hospital A with Hospital B in one big index, you've created a compliance nightmare and a data breach waiting to happen. The right approach is to provision one index per tenant, like patients, Site A, and patient Site B. Then scope your application service principal to the search index data reader role on exactly that index. This way, a misconfigured app can only see its own slice of data, and an auditor can instantly verify that isolation. It's the simplest privacy win you can implement, and it costs nothing extra. You've locked your custom skill function behind a private endpoint, but the search service still sees a 403. The real issue is often DNS. The search service needs to resolve your function's private host name to its internal IP, and that requires a private DNS zone, privatelink.azurewebsites.net, linked to the VNet, with an A record pointing to the function's private endpoint. Without it, the search engine tries to hit a public IP that doesn't exist. To test, spin up a temporary VM in the same subnet and run ANS lookup. If it returns the private IP, your indexer will too. This one invisible configuration step prevents hours of head-scratching. Manual portal clicks don't scale and they drift. A bicep module turns your entire secure architecture into a handful of version-controlled files. This snippet deploys the search service with public access, disabled, and a system-assigned identity, all in one reproducible stack. Combine it with a GitHub Actions workflow that uses OIDC authentication to Azure, and you have a deployment pipeline with 0 stored credentials. Every environment, from dev to production, gets the same locked-down blueprint. That's how you stop the "it worked in my subscription" excuse cold. Quick knowledge checkpoint. What property in the bicep template disables public network access for the search service? And what else must you do to actually enforce private connectivity? We'll reveal the answer right after. SSRF, Server-Side Request Forgery. Attacks that scrape cloud metadata to steal credentials are a known threat. In Azure, if an attacker gets a storage account key, they have full access. Managed Identity eliminates this entire class of attack because there's no static key to steal. But an even more common insider risk: a developer accidentally routes customer invoices or patient forms to a public AI analysis endpoint, thinking it's just a quick test. That data is now in third-party logs, potentially used for training. Your enrichment pipeline is just as dangerous. If your custom skill calls anything outside your tenant, you're leaking your own data. Every enrichment call must stay inside your VNet, using Azure's built-in or VNet integrated functions, so data never touches the open internet. It's the difference between a secure pipeline and a headline. These parameters will save your pipeline. Use Managed Identity for the indexer connection. No static keys, nothing to leak. Restrict public network access to harden your environment. Don't assume default timeout is enough for large PDFs. Test and adjust. Set a max failed items threshold so the indexer doesn't churn forever on corrupt documents. And for extraction mode, pick content and metadata to get full structure. Pin these as a cheat sheet. One critical advantage of building this pipeline on Azure is that you can eliminate static API keys. Instead of hard-coding a key in the skill set, you enable a managed identity on your search service. Give it the cognitive services user role on your document intelligence resource, and the indexer securely obtains a token at runtime. No key rotation, no leaked secrets. A real zero-key pipeline. A subtle but costly mistake. You train a custom document intelligence model, enrich the documents, but then forget to map the enriched fields into the index. Without explicit field mappings for each structured output, like merchant name or total amount, the indexer only ingests the raw text. The fix is simple. Add one field mapping per enriched field so your searchable data is complete. Always double-check this mapping when you add a custom skill. Time to check your understanding. In Azure AI Search, what defines the AI enrichment steps, like OCR, key phrase extraction, and calls to a custom document intelligence skill? And once enrichment runs, how does the indexer know which extracted values go where in the search index? Take a moment, then check your answer. Let's lock in the 3 skills you now own. First, you built an entirely private, keyless knowledge mining pipeline, disabling public network access and relying on managed identities from the very first CLI command. Second, you trained a custom document intelligence model on your own forms by labeling just 5 PDFs in the studio, turning scanned intake documents into structured, filterable fields. Third, you secured query access with Entra ID roles and token-based authentication, so no API key ever touches a client app or a Git repo. That's the zero-trust blueprint you can replicate for any document-heavy workload. This pipeline is production-ready. Next up in Part 11, we'll bring it under CI/CD, version-controlled index definitions, automated model promotion, and deployment validation so you never have to click through a portal again. Subscribe and hit the bell so you don't miss it, and I'll see you in the next one. Remember, careers aren't built by watching videos. They're built by applying what you learn. Pick one thing from today's lesson. Build it, document it, and share it. That's how you get hired. Thanks for watching Hired in IT. where we're turning IT knowledge into career opportunities.